Good evening, and thanks for joining us tonight for tonight's TI Technology webinar hosted by Texas Instruments. Tonight, we're going to take a look at the basics of coding with the TI-84 Plus family. I see that many of you are joining us for the first time, so we'd like to offer a special welcome if this is your first T-Cubed Professional Development webinar. We'd also like to thank everyone for completing the live survey on the right side of your screen. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. I'm really excited to introduce our panelists for tonight, John Hanna. John is a teacher from Hopatcong, New Jersey. He taught mathematics and computer science for 35 years at Teaneck, New Jersey High School. Since 1993, John's been a T-Cube National Instructor and has been honored with the Radio Shack National Teacher Award, as well as the T-Cubed Leadership Award. John now enjoys teaching teachers and traveling around the United States, discovering that we're not all that different. Thanks for being with us, John.
Hopatcong correctly.
It took me a while to get Hopatcong correct. It's like an intimidating word. I don't know, but I'm glad I finally got it.
Thanks.
We're expecting a large crowd, so your audio is automatically muted. Feel free to send questions to John or I using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. This session is being recorded, and as a reminder, we'll be sending the certificate of attendance at the conclusion of the event. Once the recording is available, if you'd like to follow along with your handheld, and that might be especially true tonight, John's going to mention that if you're really familiar with the handheld, then trying to follow along might be realistic. But if you seem to get lost, or maybe if you're not as familiar with the handheld, it might be best to just sit back and watch. And then whenever the recording is available in a couple of days, download that recording and then go at your own pace. We don't expect you to have any audio issues tonight, but if you do, try selecting Communicate in the WebEx menu, choose Audio Broadcast, and click Join. Also, I wanted to mention that if you're a Windows 10 user, we know there's some functionality issues with WebEx, and so you may not have things like the chat window available to you. At this point, John is going to discuss our agenda.
We'll start off with welcome and introductions, which we've already taken care of. But the mission here is to get teachers and especially students interested in programming. So we're going to be using the TI-84 Plus family of calculators to introduce programming to our students. TI has developed a new set of materials for teachers called 10 Minutes of Code, which I'll illustrate later on during this hour. And I'll be working with the new TI Connect CE program editor that's built into the new TI Connect software that you can download for free. So there's tons of free online resources available to you, both at TI's website and elsewhere. And at the end, Mike, don't hang up right away, but there's a giveaway at the end of the session that Mike will take care of at the end.
Thanks, John. And again, John will discuss our expected outcomes.
The first bullet, introducing the program editor to create and run a program. I'll be doing that live, and at that point you may or may not want to follow along on a handheld if you want, but I'm not going to answer questions about what keystroke was that or anything like that. Talk about editing a program. In some of the advertisements that you've received, it may have said something about selecting and copying and pasting, and we'll deal with those issues as they come up, because it's not that robust an editor. But we want to emphasize that we're going to enrich and enhance your curriculum with programming tasks for your students. And that 10 Minutes of Code material will come in real handy for you. Looks like I'm now the presenter. Let me share my desktop.
Thanks, John.
And we'll put that away. I don't know what that means, so I'll decline it. and switch to this one first. So we'll start off with a short PowerPoint slideshow about programming that I've developed along with my cohorts at the Texas Instruments offices. You'll learn more about them at the end of this slideshow. It should take about 5 minutes or less. But first, a snack. Just kidding. What does a peanut butter or jelly sandwich have to do with programming? And a lot of computer science teachers are using this method to get students to understand following instructions to the letter. Take in a jar of peanut butter and a jar of jelly and some bread, and ask the students to explain how to make a sandwich out of that stuff. And they forget to say things like, well, open the jar, or put the knife in the jar, or put the peanut butter on first and then the jelly, because you can't put jelly on top of peanut butter very well. So if you Google peanut butter and jelly sandwich and programming, you'll find lots of materials out there that talk about making a sandwich, because programming is very strict. The computer only understands specific steps, and following steps like a recipe is what programming is all about too. So why coding? I'm not going to read this to you, but the numbers that stick out on this screen to me are significant. Only 2.4% of college students graduate with a degree in computer science, and only 12% of those are earned by women. So if you do the math, what's 12% of 2.4%? Well, a student's on a calculator, hope you can see my calculator now, would tend to multiply 12 times 2.4 and get the answer 28.8. So they're saying, oh, 30% of college graduates are women in computer science. And they leave out the correct decimal points. So we're looking at less than 0.3% of graduates in college are graduating women in computer science. And that's an embarrassing number. A lot of people are taking steps to improve that number, and more about that later on too. In Texas, because the folks that originally developed this project are from Texas, of course, computer jobs are growing quickly, but Texas is the only state to require high schools to offer computer science to all students. In Texas, computer science counts as math or science credit. We also did that in my high school in Teaneck, New Jersey a few years ago, because we instituted a 4-year math requirement, and kids were having trouble passing that 4th year of math, so they opted for computer science. But that wasn't much of a bargain for the students either. It counts as credit for high school graduation. It's a certification pathway. Texas has clear certification pathways for computer science teachers, and they also have state standards. The TEKS standards in Texas address computer science as well. In your math classes, why coding in your math class? Number one, we want to expose students to the programming ideas, build a foundation. It sparks an interest in coding, and perhaps some of the students will pursue that as a career option. But I like programming because it applies and reinforces the math concepts. Writing a program is like writing a proof, except that the result is that the program does what it's supposed to do. But the programming language that's built into the TI-84s is easy to learn. It looks like plain English. In fact, they call it TI Basic. And my favorite thing is that it promotes creativity. Even if somebody else has written a program, I like to do it myself just to prove to myself that I can do something on that machine. In programming, some of the big ideas are the work with variables, input and output, logic, which is getting a short end of the stick in math content these days, and control structures. And flowcharts are still important in this particular language. Under processes on the right-hand side, it may look familiar to some of you because it's the same big idea that is the engineering design process or is the scientific method. Encounter a problem, design a solution, put it to work, and then test it, test it, test it. This is an article that was published last month on eSchool News. and it's not a local problem. It's a global problem about how to encourage students to enter the computer science field. And math teachers are part of the solution. And it's something that you can do if you know the basics. So this whole PowerPoint slideshow is going to be available to you after the meeting. So you'll be able to follow the links on these slides to yourself. And you could teach this. I know we're not talking about AP Computer Science here, but I had a look at this AP Computer Science Principles course that's coming out for the first time next year. And I believe that math teachers would find this an interesting option to expand their horizons when it comes to teaching. It's not just a programming course like the traditional AP Computer Science course that I've taught since 1984. This is a whole new idea that encompasses a lot more than just coding. TI has put together a set of materials that are available online right now called 10 Minutes of Code. These are a collection of short 10-minute activities that you can give to your students. It fits into your class without much effort. You don't need to know anything about programming because the notes that students get are thorough and easy to follow. And there are teacher notes that go along with it to follow up with questions that you might have. They've developed 5 units with 4 activities or lessons in each unit, including a programming project. And I'll demonstrate that 10 Minutes of Code site live later on. Here's one of them. It's the Unit 2 application. Write a program that asks the user to enter the lengths of the legs of a right triangle, and then compute the length of the hypotenuse and nicely display all 3 values. Flowcharts are still valuable in this language because of the way that it's developed. It's a procedural language that follows steps from the beginning to the end unless it encounters a control structure like an if statement or a loop. When you're working within the program editor, when you're writing a program in the calculator, there are a couple of tips to follow. One is to make sure that you use correct punctuation. Close your quotation marks and parentheses. The clear key can be dangerous, and I'll demonstrate that live later, but it is a useful key to use within the editor. You select the keywords from the program menus rather than type them in letter by letter. Don't worry about saving your work because it's saved as you type. If you exit the program editor, it'll take you back in, and everything you left behind is still there. Because some keystrokes, like the Y equals key or the graph key, take you out of the program editor, but you won't lose your work. If you can't find something or forget what menu something is on, don't forget about using the catalog. This is another example from the AP Computer Science Principles course outline, and I needed to point this out because, number one, it's not any particular programming language. Each question in their sample assessment uses a generic programming language, and I thought it was interesting that they should use this little left arrow key here. Hope you can see my mouse cursor, which looks like the store key on the TI-84, but it's backwards. There's no way any programming language would use that symbol as an assignment operator, but in this fake language, it works for the testing purposes. And I thought it was interesting that they should use something so similar to the TI-84 arrow key as a store operation. Unfortunately, they still have it backwards. It should go to the right, not to the left. These are my friends at TI. On the left is Kim Gonzalez. On the right is Kelly Kutach. And they are the point people at TI that are helping me with these materials, 10 Minutes of Code. We're done with the PowerPoint here, so I'm going to move on and actually do some programming with you. You may or may not want to follow along on your calculators, but don't worry about it because you'll be able to view this recording later on. I'm using this TI SmartView software on my screen. Hope you can see it properly. The program key is in the middle of the 4th row down. And I want to write a new program. Don't worry about the ones that are there. So I hit the right arrow key twice, select New. And this is where I usually make a mistake and press the Alpha key. You don't need to press the alpha key because the cursor is already in alpha mode. So I'm going to name my program A. I always name a new program A because it shows up at the top of the list. If there's time later on, I'll demonstrate how to rename a program too. Press the Enter key. And you know that you're in the program editor because it says the word program at the top of the screen. When you're in the program editor, a lot of the keys take on a whole new meaning, especially the program key itself. If I press the program key while I'm in the program editor, it brings up the programming commands on 4 separate menus. The control menu is used for the control structures, if, then, else, for, while, and repeat, and a bunch of other stuff. The I.O. menu for input and output commands. On the TI-84 Plus CE, there's also a color menu. And on the exec menu, there's other programs that you can run from within this program. We're going to start off with the I.O. menu, and I'm going to use the prompt command. We're going to write a program that computes the hypotenuse of a right triangle. In the process, we're going to explain some of the programming principles that are involved. For instance, why prompt? And the answer will be obvious when we run the program, because prompt provides the prompt for you, rather than input, which doesn't provide a prompt for you, but you can give it your own prompt. When you finish with a command, press the Enter key, and a new line appears in the editor. This is a full-blown line editor, so if you press the up arrow key, you can go back to line 1 and make changes to it on the fly. In this second command is going to ask for the value of B, so I'm going to hit the program key again, go over to the I.O. menu, select the prompt command again, and this time alpha B is the second variable. We have to compute the hypotenuse of the right triangle, so first we're going to square A and B and add them together. This is what I like about the TI-84 programming language, is that you write the statement the way you read the statement, plus B squared gets stored in the variable C. In other programming languages, you would write a statement like C equals A squared plus B squared, or C colon equals A squared plus B squared, and that's backwards. In the TI-84 language, you read the statement from left to right, and that's the way it works. It works from left to right. The arrow key is the store key, STO. One of my pet peeves about these calculators, by the way, and I don't mean to complain very much, is that some keys show one symbol on the key and a different symbol on the screen. How much we ignore that is amazing. But the store key doesn't show the word store, it just shows the arrow key. Here's the clear key at work. If I press the clear key, it erases the entire line of code that the cursor is on. It's interesting because there's no undo. If you accidentally press the clear key, it erases the entire line, and there's no way of getting it back except to retype it. One of my pet projects in class is if I see a student playing a game on their calculator, I just edit the program, hit the clear key a few times to erase some lines of code, and then the program won't work anymore. Of course, they'll just copy it from their friends later on anyway. This is not quite the correct formula for the Pythagorean theorem. We need to take the square root of that sum. So I'm going to use the square root symbol here of alpha C and store that in the variable C. Whoops, that's backwards. So I need to go back and fix my expression. It should be alpha C and then the squared symbol. And that illustrates some of the features of the editor. Oh, but that's wrong. It's the square root of C. Second square root of C. And now I need to make room for the right parentheses. So I have to press the insert key, second delete. The cursor changes from a block to an underscore, indicating that I'm in insert mode, and then the right parentheses will be squeezed in between the C and the store symbol. The reason for using this expression is to emphasize the fact that the variable on the left of the store symbol and the variable on the right of the store symbol are the same name, but they're different values. If I put in 3 and 4 for A and B, then C will be 25 on the left, but the value that's being stored in the C on the right is 5. That's a big change from what mathematics is all about, where if you see a variable in an expression, it means the same thing no matter where it is. That's not quite true when you're coding. The final step is to display the value of C. And to keep things simple tonight, I'm just going to use the display command on the program key on the I/O menu. There's a display command, enter, and the value of C will be displayed. So I'm going to display C. This is the complete program. It's saved as I type. To run the program, I quit the editor by second mode. Press the program key, select the program from the exec menu, and press the enter key to run it from the home screen. The A =? Is the prompt command at work. In response, we enter a value. For testing purposes, enter values for which you know the answer. It doesn't make any sense to enter numbers like 13 and 34. And the display command shows the result on the bottom right. Improvements to the program. If I go into the program and select Edit, Program A, instead of the display command, we could also use the output command. Producing output is different from producing a display. On the program key, I/O menu, the output command is down below. And the arguments for the output command are the line number and the column number where you want the variable's value displayed. So I'm going to make up two numbers here, 4, 5, and then alpha C, and close the parentheses. This means that I'm going to print the value of C on line 4, column 5 of the home screen. We'll quit this. Run the program again simply by pressing enter because that was the last command entered. Enter a value for A, 3, enter, 4, enter. Do you see where the 5 is? Right there. Now we need to make some improvements to the program again, like clearing the screen, displaying the 3 and the 4 properly on the screen as well. And so the program can be edited over and over and over again until things work the way you want it to work. I didn't want me to do that. Program, edit, Program A. So inside here, we're going to insert a new line. This editor lets you insert lines by pressing the insert key, press the enter key, and now I've got a blank line to enter another command on. To delete lines, you use the delete key, and the line will disappear. But blank lines have no effect on the program. I have to insert it again, enter, and go up to that line because I want to use the clear home command, which is on the program key I/O menu. Down here, number 8, clear home. The clear home command will clear the home screen. Now let's run the program again. Press enter to run it. I'm going to use 5 and 12 this time as the values for A and B. And now the screen was cleared. The 13 is displayed on line 4, column 5 of the screen. And the word done appears across the top of the screen because the program has finished. I wish there were a way of not having that word done appear, but it shows up every time a program normally ends. You can get an idea now about how to display the values of A and B as well by using other output commands. You could also display the letters A, B, and C on the screen if you put them in quotes in the output command. So one last look at the program. This output command is worth its weight in gold. When you're done, quit. I need to demonstrate another use of the output command. I have a demonstration program here called SIMPRAD4. And watch what it does first. I'm going to enter a number like 360. Enter. And it simplifies the radical. This display is produced using output commands rather than simple display commands. It's not as easy as it looks. I'm going to run the program again. When I'm testing or creating a program, what I like to do is run the program, press the on key, choose 2 to go into the program and edit it. It's a lot easier than going onto the program menu and selecting the edit and then finding the program in the list, especially if it's not at the top of the list. So when you're working on a program, if you press the on key, that breaks the program or stops the program, and then you can choose either go to edit the program or quit to go back to the home screen. Somebody just said yikes, and what they're referring to is this third output command in here. What is that all about? And what I did here, and this is the importance of using mathematics in programming, the expression int log n plus 1 is simply the number of digits in the number. And so this knows how many digits are in the number. So this output command knows where to put the right parentheses at the end of the number. The algorithm is tricky, and you notice that I had 4 different versions of this program. So there was a SIMPRAD 1, 2, 3, and 4, and I was trying to get as efficient an algorithm as possible. That was the puzzle that I forced myself into playing around with. So it's not a straightforward operation here. Programming can get complicated, but it applies a lot of mathematics. The 10 minutes of code activities are not as complicated as that simplifying a radical project. They're much more straightforward and hopefully useful to the students, or at least entertaining.
Hey, John.
I'm going to switch gears. Yes.
Sorry to interrupt. We had actually 2 questions regarding the TI-83 Plus. Will
yes.
the coding that you're doing still be available and work on the TI-83 Plus series?
8XP programs will work on an 83 Plus, yes. You can transfer files from an 84 Plus to an 83 Plus. And somebody has to show that again. Let me just put that on the screen. This one. And if you'd like a copy of this program, my website is on the PowerPoint slideshow. So you can contact me through the website. There's a contact me section on there, and you'll have a copy of that PowerPoint file as well.
Thanks, John.
Yeah, the programs like I'm writing here work on the 83 Plus, the 84 Plus, and the 84 Plus C and CE. There's nothing special about them except for the graphics that are involved. So if you avoid the use of color, you can get programs to run on any platform from the 83 on up. Speaking of 83 and 84, if you're interested, the 10 minutes of code activities they take into account the differences in the screens, but it's possible to write the same program that runs on an 83 and an 84 Plus and an 84 plus CE. This is the same program running on 2 different platforms. There's a big difference in screen resolution between the 84 plus and the color models. The 84 is 95 by 64 or 96 by 64, and the CE is actually 264 by 164 or something like that. So getting a program to work on both means you have to take into account those 2 different screen sizes in your code. For the 10 minutes of code activities, we don't address this except to mention it to the teacher notes, that the screen size, the graphic screen sizes are different, and the home screen sizes are different. I think on the 84 plus, the screen is 16 characters wide, and on the CE, it's 26 characters wide. Let me get into this website, and this is education.ti.com, the home page. You'll find the 10 minutes of code activity. Where's the top page? Oh, normally you find things under activities, but they didn't put the 10 minutes of code activities underneath activities. They put it underneath solutions because the activities focus primarily on math and science activities, I suspect. But you'll find TI codes down here at the bottom of the solutions menu on the home page. And now we're into the TI Codes site, which is a pretty exciting website as far as coding is concerned itself. So we have these 3 buttons down here on the lower left, 10 minutes of code. Beyond the basics is a couple of programming projects that were developed to take you past the 10 minutes of code stuff. And then the Teacher's Lounge. If you start here under 10 minutes of code, these are the 5 units that are provided to you in 10 minutes of code. The basics and displaying stuff on the screen using the display command and the output command that I just showed you. Unit 2 is on using variables. Unit 3 is on conditional statements, if then, and if then else. Unit 4 is on loops, for loops, while loops, and repeat loops. And Unit 5 is on the fun stuff, the graphics. Earlier I used Unit 2 application, so I'm going to jump quickly into that section just by clicking on this blue bar. The bar opens up, expands downward, and here's Skill Builder 1. But we can go on to Skill Builder 2, Skill Builder 3, or the application. And I'll just illustrate the application here. Write a program that evaluates a formula. We can follow this through step by step. And this is all public domain stuff here. This is available to everyone, so students can do this on their own. And here's the Pythagorean theorem activity. It's a little more elaborate than what I wrote earlier because of time constraints. But you can follow these step by step on screen and have a program finished at the end. The applications do not contain step-by-steps for the codes. For instance, here's a project to compute the area of a triangle given the 3 sides, Heron's formula. The code is in the teacher notes. If you want to see the solution, you go back into that Teacher's Lounge. We'll take us back to the home page by clicking on TI Codes up here. If we visit the Teacher's Lounge, this middle button here, all teacher and student notes, will give you a zip file of all the materials. The student activities are 1 to 2 page documents for you to hand out to your students, and the teacher notes are a bit longer. They're just copies of the student activity with comments in it for the teacher. It also includes the programs themselves that the students are expected to produce, so you can see what the correct program would look like. And that Teacher's Lounge, all teacher and student notes will give the teacher everything they need to do to implement the 10 minutes of code activities in their classroom. At the top of the page you'll also see a link to the teacher notes on all of the activities. So if you're working through these step by step, Let me go into one activity. There's a teacher notes up here for Skill Builder 1, and this is the Skill Builder 1 teacher notes as a PDF file. So I'm going to put 10 minutes of code aside for a moment, minimize that one, and talk about where's that software running. I'm going to close down this emulator software. How are we doing on time? Pretty good. And bring up TI Connect CE. If you haven't downloaded this, this is totally different than the original TI Connect software. In the original TI Connect software, you were faced with a home page with like 8 or 10 icons on there. And the new software is designed much more simply. All we have are these 3 tools on the left-hand side: a screen capture utility, a calculator explorer, and the program editor. I don't have a calculator connected to my computer, so I'm going to switch right down to the program editor. And this is what I want to emphasize in here. We can write programs right here in the computer, but we can't run them. If I want to write a new program, I just click the New Program button here, and then I can choose my commands, excuse me, choose my commands from these menus on the left-hand side, or if I know how to spell them, I can just type them in. So this command is a prompt command. And if you feel like typing your commands in, you can get them right here, or you can get them from the menus that appear on the left. So here's another prompt command. And you can use the variables of your choosing in your programs. I'm going to open up a program. In my webinar folder, the program NIM is a demonstration. So I don't know how many of you have heard of the game of NIM. You have 3, 5, and 7 sticks, and you're supposed to take away as many as you want on your turn, and the person who picks up the last one either wins or loses the game. So this is my current project. So far it works with 2 players, but I'm trying to figure out a way of getting the computer to play against a human, and that's the hard part. All of these commands that you see in here are selected off of the menus on the left-hand side of the screen. To get the program to run, what I usually do in this software is send it to a connected calculator and try it out on the calculator. That's the most efficient way I've found to do it. The other option is to save it on your computer and then load it into the SmartView software, but I find that it's faster and easier for me to send it to a connected calculator than it is to switch between the Connect software and the SmartView software back and forth. That way this can stay on the screen all the time. I can run the program on a calculator. If it doesn't work the way I want it to, I just come back here and make changes to this code and send it to the calculator again. It's a lot simpler than using the SmartView emulator software. So this new program editor is built into the TI Connect software. If you don't have it, make sure you get it, because when you're writing larger programs, it's easier to type things in than it is to pick them off of the menus on the calculator. But a word of caution about typing this stuff in. You have to type it in exactly as it appears if you were to pick it off the menu. So that CLRHOME command that I highlighted, the C has to be capitalized and the H has to be capitalized. Otherwise, it won't work when you send it to a calculator. One of the more frustrating commands that I had to deal with on this program editor is the pause command. It's spelled P-A-U-S-E and then a space. And if you leave out that space, it doesn't recognize that command at all. And that's why it's a good idea, if you're a beginner, pick the commands off of the menus rather than type them in yourself. So that's the Connect program editor. It's a powerful tool to be able to write programs in the computer rather than have to rewrite everything in the calculator.
Hey, John.
One other feature, yes.
Sorry, before you continue, Mark had a question. Is it possible to lock a program from editing?
I was just about to mention that. Thanks. You see this little lock icon in the top right side of the program? If I check that, the program will be locked when you send it to the calculator. That means that you won't be able to edit the program within the calculator at all. And it's going to be protected from editing with this little lock button. This was in the original TI GraphLink software feature, and it's been resurrected here in the program editor here too. The programs don't show up at all on the edit menu if the program is locked. No, you cannot lock a program on the handheld. It's only in this computer software that you can write protect a program. So to lock a program that's on a calculator, you can dump it onto the computer, open it up in this editor, unlock it, and then send it back to the calculator and it will work. If there's a locked program on the calculator and you want to unlock it, just to load it up into this editor and then send it back to the calculator in the preferred state. So in my computer, I have both locked and unlocked versions of important programs. Some that I can edit on the calculator if I'm riding in a plane and I have 2 hours to kill and I want to play with programs. It's easier to program them on the calculator in a plane than on this clunky computer that I have to lug around with me. So writing programs is now again possible thanks to this new TI Connect CE software. Any other comments about this that I need to know about, Mike? I'm going to close this down and go back to SmartView.
Yeah, as you're doing that, Raylan just had a quick question. She just wanted to double check that as far as like using the cable and connecting it and trying to get that connection, her comment is, and we can now connect calculators using either that clear gray cable or the USB cable, and that her understanding is that we no longer have to use a serial connect to program on a PC.
Correct. I think everything works through USB now. Those old gray, the silver GraphLink cables are a serial cable, and the new calculators, the 84C and the 84CE, don't even have those serial ports on them anymore. Oh, good question from Leslie I just spotted. Can we do this with the Inspire? Yes, TI Inspire has a robust programming language built into it, similar to this. The syntax is pretty much the same. The commands are a little bit different. There's new features in the Inspire because it's a completely different operating system. But programming commands are selected from menus. If you open up a calculator page on a TI Inspire and look at the menu, down at the bottom of the menu there's functions and programs, and you can write programs within the calculator, within the Inspire as well, just like this. In fact, that was one of my missions, is to rewrite that simplifying a radical program on the Inspire as well and see if it performs any differently or better. Let me put this aside. No, I don't want to save this. No, I don't want to save this. Go back to my SmartView software. I'm working on a computer that's about 6 years old now, so I don't want to strain it too much by running too many programs at the same time. And another cool feature about SmartView is that it picks up right where it left off. This is the way I left the software when I closed it down. Quit. I have about 5 or 6 minutes left, I think. I want to talk about it for a second, renaming that program. Remember I called my hypotenuse program A, and I don't like that name. Once I'm done working on a program the first time, I'd like to give it the correct name instead of just calling it program A. So this is how you rename the program. On the program key, go over to New, create a new program, and give it the name that you want the program to really be. So I'm going to call it HYP, and press the Enter key. By the way, if there were already a program HYP in my calculator, it wouldn't create a new program. It would just bring up that one. Inside the program, I don't want to have to rewrite all that code. Instead, I'm going to recall that code. This is a key that's very seldom used on your calculators. Press second store. That's the recall key. At the bottom of the screen, the word recall appears, and now you have to tell it what variable you want to recall. So I press the program key again, go over to the exec menu, and select program A. Now the command at the bottom of the screen says recall program A. When I press the enter key, all the code that was in program A is now pasted into program HYP. This is a handy way. This is the one way that you can use to copy and paste code from one place to another. But it copies the entire program, not just a few lines of code. So this is now the correct program. I can go back and delete program A by pressing quit. Program A is still on the menu, but now there's also a program called HYP further down on the list. It'll take a while for me to get to it. There it is. And program A and program HYP both contain the same code. I can delete program A. To delete a program, use the memory management tool. Number 2 on the mem key, second plus is the memory key. Memory management. I want to deal only with programs, so I'm going to press 7 for program. And then when the cursor is pointing to the program you want to delete, simply press the delete key. With programs, you get the option, are you sure? And the default is no. You have to choose yes to delete the program permanently from the calculator. And it's gone. Second quit, back to programs, and you see that program A is now gone. The exec menu and the edit menu are two different menus. If you look on my screen, you see number 8 says calendar and number 9 says calendar P. If I look at the edit menu, I see calendar and then number 9 says CE or plus. The calendar P program is locked for using the TI Connect software. A locked program will show up on the exec menu, but not on the edit menu. So the calendar P program is the protected one. That's why it ends in a P. The calendar program is the unprotected one. So you can lock programs using the TI Connect software. If you're wondering, the calendar program displays the current calendar. So this is 11/2015, and this is the calendar for this month. The arrow keys let you go advance a month or back a month, or advance a year and back a year if I use the right and left arrow keys. And this is one of those programs that works on either an 84 plus or an 84 CE, despite the differences in the screen sizes. So if I press the on button, this is not a good idea to do, and choose go to, it goes into the code at the spot where the program was paused. I'm going to stop that. I can't stop it until it finishes scrolling. Another thing I learned about this SmartView software is that if a program is running, then the Calculator Explorer doesn't seem to want to transfer files back and forth. Let me quit that and go to Program, Edit, Calendar. This takes me to the top of the program instead of down in the middle. And these first few lines of code, 0 is stored in Xmin, 1 is stored in Delta X, If Xmax is greater than 95, then, and I store these two values in two variables. Otherwise, I store these two values in two variables. This if statement is the key to knowing whether you're working on an 84 plus or an 84 plus CE. On an 84 plus, Xmax would be 94. On an 84 plus CE, it'll be 264 or something like that. So this is a way of telling which device your program is working on, if you care. For most students, and again, in the 10 minutes of code, this is not addressed. And I didn't figure this out myself. I had some help from someone at TI who demonstrated this little trick. But it's not a hard thing to do. And the numbers here then are going to be used later on to scale the screen properly. Quit. I mentioned differences in the 84 plus and the CE. On the CE, the window commands are all the same, except that zoom decimal is a little bit different on a plus and a CE. But it's the text command that really makes this thing display a calendar in here. There's a lot of text commands in this program, and text commands are addressing the pixels on the screen rather than the points on the screen. I'm going to clear the screen, quit, go into y equals, graph a function, sin x. Make sure you close your parentheses even though you know it's not necessary. Hit the graph key, or zoom decimal, and the axes are turned off. These are points that are being plotted. The text command on the draw menu can be used in a program to draw text. It's down below. We don't need a program to draw text. I can just put my cursor in here, press the Enter key. Now, I should have been on the home screen, sorry. Let's do draw text again. Text at 10, comma, 10, comma, and then in quotation marks. Use alpha lock to lock the quotation marks on, and we'll just type a few letters, and then close quote and close parentheses. Close parentheses. That's not a closing parentheses. I have to turn off the alpha lock to get the parentheses, and then the Enter key. So the NOP is displayed at 1010, but that's the 10th row of pixels and the 10th column of pixels that are on the screen. It has nothing to do with the window settings. So drawing text and plotting points are two different operations in here. And you notice how the letters NOP are in blue on a white background? I haven't figured out how to change that white background to yellow. I can change the text color, because on the draw menu, there's a text color command somewhere in here. It might be in the program editor. But I couldn't figure out how to change the text background command, the color of the background of the text. This is all still very new to me, the color calculators. It's in the VARS key, thank you, under color or under text. Nope, not in there. Never mind. Okay. Again, the 10 minutes of code activities are not as elaborate as this stuff. They do some text commands in the Unit 5 on graphics, working with text commands and plotting points and drawing lines and things like that. But the program editor is fairly friendly. If I type in, watch what happens here, A, enter. Here's a simple program that does the same thing I did earlier, but it's just one line of code. If I run this program, what do you think is going to happen? I'm glad people are answering these questions for me. I see them popping up on my screen, but apparently a lot of people are helping me out here. This program uses the values of A and B and stores them in the variable state. Watch what happens when we run this program. Program, choose A as a program, and it produces the number 2016.03001. How is it getting that answer? Well, the values of A and B can be displayed here. A is 2016, must have come from that calendar program, and B is 11, again, must have come from that calendar program. The program uses the same variables that are built into the calculator, the 27 letters of the alphabet, A through Z, and theta. So I see I'm running short on time. I can go on forever with this stuff, but I'm going to pass the mic over to Mike. How do you like that? And I'll let him finish things up for you. Thanks for your time, and remember that this session is being recorded. I'm sure he's going to remind you of that too, so you can review this stuff later on.
I sure will. So thanks so much.
I have to shut off. I have to stop sharing. Thank you. There we go. Back to Mike.
Thanks, John. So we are going to begin wrapping things up tonight. I know a lot of you are planning on attending the T-Cubed International Conference in Orlando, Florida. You can certainly visit our website to get more information as far as pricing and other information as far as what kind of things you might be able to see there. But things like John presenting tonight, that's not unusual to see things like that at the International Conference. I'm pretty sure that John will be attending. I'll be attending. But there's a good chance that John and I both can be presenting different things at the conference. And so it's a great place to connect with other educators and learn some new things. Earlier we mentioned that we're going to be giving away 2 free registrations for that international conference, and tonight's lucky winner is Terry Reck. So Terry, we'll be in touch over the next couple of days over email. Congratulations, and we really hope to see you there. To receive a certificate of attendance, go ahead and click that link coming up in the chat window right now. Also listed is a link to the documents. A lot of you were looking to get John's email address because you had some questions that maybe weren't answered tonight, or just looking to get more information. And so if you download the documents for tonight, John had a PowerPoint, and the title slide of that PowerPoint had John's website and email address. And I know John is really receptive to helping other educators learn more about the technology and especially with coding. So please feel free to contact John. I know he'd be looking forward to it.
Thanks, Mike. I'll also be at the NCTM Regional Conference in Minneapolis this Thursday, and I'll also be at the Nashville Conference in next Thursday, promoting coding in your math classes. So stay tuned. There's going to be a lot more to come down the road, too. Those of you who are looking for TI Inspire materials, hopefully stay tuned.
Well, thanks so much, John. I think it looks like a lot of people tonight had some really positive things to say. We haven't done a coding webinar, I think, at all, ever. So this is kind of breaking new ground for us, and it's really great to see some people that are really excited about learning about this material. And John, thanks so much for putting it together for us tonight. I really appreciate it.
My pleasure. May the force be with you.
Thanks so much, everyone, and we hope to see you back online next week. Thanks so much. Have a great night.
Good night.